Welcome to the Organic Chemistry Podcast, Dr. Brian Lloyd's scribblecast of organic chemistry lectures and solutions to problems. In this lecture, we're going to take a look at functional group nomenclature. We're going to examine a series of different types of functional groups and examine the nomenclature for those molecules, both IUPAC and common. We're going to begin by looking at the nomenclature of alkenes. If you remember our functional groups that were given in previous lectures, alkenes are molecules that possess a carbon-carbon double bond. So they are molecules that possess the carbon-carbon double bond. The IUPAC name, is derived from the alkane name. The only difference is we drop the ane and we replace it with ene. The best way to begin is to examine a molecule that has a double bond in it. So let's try something like this. When naming a molecule that possesses an alkene, you find the longest carbon chain as usual, numbering through the double bond. So we have 1, 2, 3, 4, 5 carbons. Equally, we could number the alternative way, 1, 2, 3, 4, 5 carbons. Now we pick the numbering along the chain that gives the lowest number to the double bond. You always must number through the double bond. That is, if 2 is at the beginning of the double bond, 3 must be through the double bond. Secondly, the number given to the double bond is the lowest possible number at the position of the carbon that the double bond begins at. So what we here have is a 5-carbon chain. A 5-carbon alkane is a pentane. Because of this, this would be a pentene. Now, prior to 1993, we could name molecules such as this as 2-pentene. After 1993, IUPAC favored an alternative name. Now, this alternative name was acceptable prior to 1993, and you actually had a choice. You could put the 2 outside the pentene, or you could move it in near the functional group, and you'd say pent, to, ene. Both names prior to 1993 were acceptable, but after 1993, according to IUPAC, the proper name would be where the 2, which is called the locant, that number that localizes where the double bond is placed right next to the functional group name. So in this molecule's case, pent-2-ene is the best name. Now, as far as this course is concerned, I will accept either. All right? I will accept either. What happens if you have 2 double bonds in your molecule? What happens if there are 2 double bonds? Suppose I redraw my structure so that I add a double bond here. Now, with 2 double bonds, we indicate 2 by the prefix di. And so when this is a 1, 2, 3, 4, 5 carbon derived from pentane, we're going to now make a pentene. And when you go to more enes, you add the proper prefix. For 2, you use di in front of ene. For 3, you use tri. For 4, you use tetra. But what's interesting is you add an A in front after the pent. So you actually get pentadiene, pentatriene, well, you get the idea. So here's pentadiene. Now the question is, what numbering scheme works? Last time we had 2. You pick the lowest possible numbering scheme. If we number from left to right, this numbering scheme gives us an ene at 2 and another ene at 4. The top numbering scheme gives us an ene at 1 and an ene at 3. What is better, a 1-3 or a 2-4? Well, a 1-3 is definitely better than a 2-4 because it's lower. Again, notice numbers are separated by commas and from words by hyphen. Now, this is the name that was acceptable prior to 1993. If you are actually going to place this name the proper way, penta-1,3 diene would also be acceptable. Okay, so there are 2 examples of some alkene names. Let's try a new one and put some substituents that we've learned about from last lecture on the chain. So let's just erase this if we can. And there we go. What we'll do now is we'll just try a cyclic structure. How about that? Let's try something cyclic. Okay, how about something like this? 6-membered ring. And let's put a double bond here. Double bond here. Actually, let's just put 1 double bond in to start with. Couple methyls, and let's put in another side chain. Okay, so what we have here is a carbon ring with a double bond in it and several substituents. The first thing to note is that the longest carbon chain is the ring itself. What we have here is a 1, 2, 3, 4, 5, 6 carbon chain. A 6 carbon straight chain is a hexane, but if it's in the ring, it gets the prefix cyclo. Now, many students will forget the prefix cyclo, and you want to make sure that you do not. So this is a cyclohexane, but because it has a double bond, it becomes a cyclohexene, all one word. All right? Now, we have to figure out where the double bond is. Now, what's interesting about a ring structure is you can start numbering wherever you want on the ring. So I could start 1, 1, 1, 1. I have to give the lowest number to the alkene root. And if I'm going to number the alkene, number 1, I want to make clear that I cannot do this. 1, 2. In a ring, if you're going to number one end of the carbon as number 1, the carbon that bears the double bond, you must take the other carbon that bears the double bond, and it must be 2. You have no choice. The very fact that you pick this carbon as 1 means that this carbon must be 2. No choice whatsoever. If, however, you pick the other end as carbon 1, then you could pick the other carbon as 2. In fact, I'm going to use a different color. So let's show our numbering. We've got 1, 2, 3, 4, 5, 6. Or we can use the red. Number the other way. 1, 2, 3, 4, 5, 6. Okay, now both methods give the cyclohexene number 1. So since the cyclohexene is 1 no matter which way, it doesn't matter from the Ynes perspective what you use. So it will be the lowest numbering of the substituents that will determine which numbering scheme you use. Now you'll notice the reds give you a 3,5 dimethyl. So with the reds, I get a 3,5 dimethyl. If I use a blue numbering system, I get a 4,6 dimethyl. That's higher numbers. What about the nitro? The nitro in red is a 4, NO2 is called a nitro group, nitro. Well, that's better than 5. So it looks like the red numbering is the best. So what is the name of this molecule? Well, we have to use alphabetical naming for the substituent, and di is not used, so I use the M of methyl and the N of nitro. M comes before N, so this should be a 3,5 dimethyl four nitro and then 1 cyclohexene. The alternative name could be 3,5 dimethyl four nitro cyclohex 1 ene. Okay, both names are acceptable in this course. What's interesting in this case, you could also drop the 1. You could have written 4-nitrocyclohexene because the alkene is the highest priority group in this ring. It must be numbered 1. It is more important to give the alkene a number 1 ranking rather than any other group. And because of this, since no matter where the ene appears in a chain, it would have been given number 1, you could drop the 1. Now, if this is confusing to you, you don't have to worry. When in doubt, put the 1 in. I will never dock you marks for including the 1. However, you can occasionally drop it, but you only can drop it if there's no other possibility for the alkene. And if you're ever in doubt about that, well then, just leave it alone. You don't have to deal with that. We're going to bring up functional group priority more and more. So after we're done some more alkene names, we're going to examine that. In fact, now might be an ideal time to do that. So why don't we jump ahead a little bit and talk about functional group priority. It turns out there are functional groups that must be numbered the lowest possible number, if possible, or above and over all other functional groups. And the ranking for these functional groups that you need to know are as follows. The highest ranking group that in the list of those you have to know is the carboxylic acid. CO2H. This is followed by the aldehyde. So C double bond OH, sometimes written CHO. CHO. Okay, CHO is an aldehyde group. This is followed by the ketone, who does not have the H. Okay, and this is followed by the alcohol group, which is followed by the amine group. And because you can have H's or carbons, we'll put an R2. R could be H or carbon. This is followed by the alkene, which is followed by the alkyne, which we're coming up to in our nomenclature rules. And then below that we have our alkyls like methyls, ethyls. We have benzenes such as phenols. We have our halogens, chloro, bromo, fluoro, iodo. The one we just did, our nitro, and other groups. These are the lowest priority. So this is increasing priority in this direction. Increasing priority for functional group nomenclature. So if we start mixing up functional groups, which one is named in the root, whether you use the "ene" ending or not, is determined in many ways by functional group and the priority of the numbering system as well. And so we're going to see this later on, and it's important that you be aware of this as we come through this section. Now there is one little exception to prioritization, and that's these guys. When there's just these two present in a molecule, we do have a little exception which we're going to examine. So you're going to hear me using the term throughout the rest of this lecture of priority group. And I'll be drawing your attention to the priority group and why it has to get to the lowest number and whether it's in the root name or not. And so we'll be talking about root names, priorities, and you need to be aware of this ranking, and you should memorize this ranking. This ranking has to be known. So let's go back to our alkenes. And now we're going to add into the alkenes the alkyne. And then we'll start combining both into molecules. The alkyne, as we know, are molecules that consist of the triple bond. They are named in IUPAC nomenclature by taking the alkane and replacing the ane. So you take the alkane name and you replace the ane and add yne. So that seems to make reasonable sense. So if we took a look at a molecule such as follows. I always start by finding the longest carbon chain, and we name it. Longest carbon chain, 1, 2, 3, 4, 5, 6. 6 carbons is a hexane. A hexane with one triple bond becomes a hexene. So let's do that. We start with hexane. If there was no triple bonds, this would be a hexane. If there was one triple bond, we drop the ane and add yne. When there's 2 triple bonds, we add the prefix di in front of yne, and we make it hexa. We add an A and say di-yne. If there were 3, we'd go hexa tri-yne, and so on. Tetra-yne, penta-yne, hexa-yne, hepta-yne, octa-yne, so on. Well, we have a hexadi-yne. And again, we have a long chain, so we have 2 ends to number from. I could go 1, 2, 3, 4. If I go this way, I've got a 1, 3. If I go the other way, 1, 2, 3, 4, 5, I'm going to get a 3, 5. Well, what's the lowest numbering scheme? A 1, 3 is a lower number scheme than 3, 5, so this becomes a 1, 3 hexadiene. Of course, the better name, according to IUPAC rules, is hexa 1, 3 diene. And so we can do the exact same thing that we practiced previously. Let's try a new cyclic molecule. Again, this is shrinking so much you might not see my carbons, so I'm going to put dots in to show all my carbons, so it's easy for you to see them. And I'm going to make a molecule that probably can't exist, but nevertheless, for fun of naming, I'm going to put 2 triple bonds in it, right there. Well, if this was an alkane, it had no triple bonds, 8 carbons, an 8-carbon chain is an octane. In a ring, it's a cyclooctane. This would be a cyclooctine if it had 1 triple bond. With 2, it becomes a cycloocta diene. Now we can number. In a ring, remember, you must number through the triple bond. We start at a triple bond because it's a higher priority group than a plain carbon. 1, 2, 3, 4, 5, 6, 7, 8. Now you can try numbering different ways and you'll never be able to beat that number as long as you're forced to follow the rule. If you put 1 at this position of triple bond, then you must have 2 numbered through the triple bond. And in this case, we see we've got a 1, 5. And of course, you can say cycloocta 1, 5 diene. So the alkyne nomenclature works very much similarly to what we've seen in the alkene nomenclature. But what happens when you get a molecule that combines both nomenclatures in a single molecule? Let's go with this. What about a molecule like this, where we have several double bonds and maybe 1 triple bond? Well, the first thing to note is that there is no way of bringing, a simple way of bringing an alkene out front as a prefix name, as a substituent. And so this is one of the rare cases where you're going to put 2 groups in the root. In other words, a 5, let's count this, 1, 2, 3, 4, 5, 6, 7. A 7-carbon alkane where there are no doubles and triple bonds is a heptane. What happens is for enes you get heptene, for ynes you get heptyne. So we need an order. The ene root always precedes the yne root. So you will have a heptenine. Okay, so if you have 1 ene and 1 yne, you'll get a heptene yne. Now, because there's 2 alkenes, we have to use the di prefix and then create the hepta. So insert your A, hepta, add the di, diene, and then you get the yne. Now notice the di only affects the functional group it's in front of. So diene means there's two enes, but there's only one yne. If I had two ynes, I'd have to say diene, diene. If I only had one ene and two ynes, I'd have to say heptene, diene. So you'd notice there wouldn't be no A there. Hepta, the A appears because of the consonant D that appears. And so the A is always inserted, but it's not inserted when the vowel is retained. And by the way, you might wonder what happens to this E. This E disappears when it is silent. If the E is silent, so if the vowel is silent and it's followed by a hyphen or another vowel, the E is dropped. Okay, so we have hepta, diene, yne. Now we have to number this, and I'm going to put the numbering scheme down. Both possible numbering schemes down. And below that we have, and I'll put that in red, 1, 2, 3, 4, 5, 6, 7. Now, I want you to look at the ranking for priority groups, and based upon ranking, tell me which methodology would be supported. If you check that carefully, you see that the double bond alkene is above the triple bond alkyne, which means alkene's higher priority. But we have to be careful. It turns out if alkene priority was simply used, we would use the blue numbering system. But it is circled and the exceptions mentioned. And the exception works like this. If there's only double and triple bonds in your chain, even though alkene's higher priority, forget that and just go for the lowest numbering system, for the enes, ynes combined. So what do we have to do is compare. We have to compare a 1, 3, 5 numbering system to the 2, 4, 6. Well, what pattern is lower? What pattern is lower is the red pattern, 1, 3, 5. Now, you must assign the proper numbers to the enes. Hepta, diene, yne, the 3, 5 applies to the enes. So 3, 5 hepta, diene, and then you have to put 1 yne. Is the 1 required? Well, yes, the triple bond could have been any place else in the chain. You could move it in other positions in the chain, so you must use the 1 to indicate where the yne is. All these numbers are required. The better IUPAC method since 1993 is hepta hyphen 3, 5 diene 1 yne. Okay. Now, what you notice here is we picked the lowest number, even though the lower priority group was given the lowest number. This is the only time we do that. Normally, all other groups will give the lowest possible number to the highest group, even if we took all the groups together, there was what might appear as a lower numbering system. So this is an exception, and you have to watch for it. It can be tricky. Now, so far we've covered a lot of molecules of enes, ynes. I do want to indicate that we've been giving you the structure, and you had to generate the name. And I think you should practice naming all these. It's worthwhile to listen to the lecture, but it's much more beneficial if you actually go back and take the time to cover up the structure and try naming it yourself. But you must also, when given the name, be able to draw the structure. So how do you do that if, say, you actually were given this name? Well, it's not that difficult. That's why I haven't been doing many of these. But all you have to do is realize that hepta comes from heptane. And that means 7 carbons. So you write down 7 carbons. 2, 3, 4, 5, 6, 7. And then it says 3,5-diene. So you count 1, 2, 3, and put a double bond after carbon 3, 4, and a double bond after carbon 5. After carbon 1, you put a triple bond. Now you just add your hydrogens. And once you're done, you've drawn your structure. So for us to draw a structure, so far it's not difficult. So far it's pretty basic. Just remember, get out of the name the longest chain, and then assemble the substituents, either from the root or wherever the substituents come out in front in the prefix. So drawing the name is not too difficult at this stage. But again, you should be practicing this. All right. What other functional groups do we have? All right. Or substituents? Well, we do have some common names for some substituents and some common names we can use as substituents that you need to know in the alkene-alkyne family. And we're going to draw some of them now. You may come across a rare situation where you have a situation that you can name an alkene like this. Now, or you may have this alkene as a substituent on a long side chain where it's not incorporated in the root name for some reason. So you might have a long side chain here. The group here is called a vinyl group. Now, when there's a chloro on, the IUPAC name is 1-chloroethene. A 2-carbon alkane is ethane. When it's a double bond, you drop the ane and add ene, and we have a chlorine at carbon 1. But the common name is to name these chloro groups as chlorides. I mentioned that last lecture. So we would commonly call this a vinyl chloride. Another group like this is a group which has a double bond, like the vinyl, but instead of attaching through the chain right at the sp squared carbon, there's a CH2, and that has a halide or perhaps a squiggle attached to it. This group is referred to as an Allyl group. If I was to do an IUPAC name for this, I'd find the longest carbon chain, 1, 2, 3. Where would you number from? Should bromo get the 1 or should the double bond get the 1? Well, double bond's higher priority than bromo, so you would number this way. And so this carbon in IUPAC would be a propane, 3-carbon, alkane's a propane. Add the double bond, you drop the ane and add ene, it's a propene. Okay. In actual fact, no matter where I put the double bond, it's a 1-propene, but I will put the 1 in so it's not confusing. And so we get a 3-bromo, prop, 1 ene. Or you could say 1 propene. Now, what is the common name for this? Well, this whole group is called allyl. So the common name is an allyl bromide. Okay, so we got some new common names based on double bonds. What about triple bonds? Well, it turns out there's one a lot like allyl, but instead of off of the CH2, you have a double bond. Off of the CH2 this time we get a triple bond. And this could be attached to a squiggle, or a long chain would be called, or it could be attached to a halide. Let's make it an iodine this time. This group is a strange sounding name, and it is called a Propargyl group. A Propargyl group. Now, Propargyl, under IUPAC nomenclature, we have 1, 2, 3. The alkyne's higher priority than I, so he gets a 1. So this is a 1-propyne, or prop-1-ine, with a 3-iodo. So the IUPAC name is 3-iodo 1-propyne. Or the common name uses Propargyl, and it would be called under common nomenclature Propargyl space iodide. Common names have a space between the halogen ending and the Propargyl. If there was an OH there, it would be called an alcohol, but we haven't covered that yet, so we're coming to that, so I'll stick with halides. Okay, so we've got 3 new functional groups used in common nomenclature that are based on alkenes and alkynes, and that is vinyl, allyl, and Propargyl. We do have some we have already covered that do have double bonds in them. There's this group. The IUPAC name is to name the longest carbon chain. In this case, a 6-carbon chain with alternating double bonds is called a benzene. So I would call this a 1-bromobenzene. Benzene has alternating double bonds, so you don't have to give numbers for the location of the double bonds. This is IUPAC. The common name for this is to name this like an alkyl group. And remember, last lecture we learned that this is called a phenol. So the common name would be phenyl space bromide. Notice 1-bromobenzene has no space. If it looks like there is one, I apologize, but there is no space here. This is all one word. So that's a common. A molecule like this guy has a little more complicated IUPAC name. There's no simple name for CH2Br in a side chain. And so CH2Br must be named in brackets if there's no simple name. And so yes, we get a benzene in the IUPAC name. And in brackets, we have a bromomethane or bromomethyl. So it's a methyl group off a benzene. I need more room. Might be easier just to write methyl and then bromo. So methyl, still not enough room. Bromo. And we need some numbers here, so I'm going to move this back. Okay, let's put the CH2 on the other side. Same thing. So here's my bromomethyl, and the bromo's off carbon 1. There's only one carbon, so I don't have to put a 1, but I could. So if I wanted to, I could say 1 dash bracket 1 bromomethylbenzene. Remember what this group was called? Sometimes the common name is easier than the IUPAC name. That was a benzyl group. Its common name is benzyl space bromide. So these are examples. These common names are examples of some specialty names for groups with double and triple bonds. So we've learned the terms phenol and benzyl already, and today we learned vinyl, allyl, and propargyl. All right. What we're going to do next is start looking at other functional groups. Right now, we're going to take a look at alcohols. And from this point on, we're going to notice some differences in functional groups that I will draw your attention to that separate these functional groups from the nomenclature used for Ynes and Ynes. So you want to watch for that. First off, alcohols are named under IUPAC by finding the longest carbon chain, taking the alkane root, dropping the E and replacing it with OL. So, if I take CH3, CH2, OH, and I want to name this under IUPAC, I find the longest carbon chain, 2 carbons, an alkane, 2-carbon alkane is an ethane, drop the E and add OL, this is ethanol. What's interesting, and that's IUPAC again, what's interesting is the common name is a lot like what we do for alkyl halides, where we name the alkyl group as what it would be. Ethane, you pull an H off, put it as a side chain, it becomes an ethyl. And then you put a space. If it was a halogen, it would be a bromide or a chloride. But what is an OH functional group? It's an alcohol. So this is ethyl alcohol. So whenever an OH appears, the common names are called alcohols. What about something like this guy? This one's tricky. Let's see if you can catch this, okay? I'm going to try and lead you astray here. Longest carbon chain, well, again, I've got 2 carbons with an alcohol. So this is an ethanol with a methyl. So tell me what you think of the name. Well, you might say, why didn't we call it 1-ethanol? Just before we go on. And I did call it 1-ethanol because if I put the OH at the other end, it doesn't matter. It's still 1-ethanol. So could I call this, could I call this guy 1,2,1-methyl? Ethanol? What do you think of that name? If you say that's wrong, that's correct. It's not right. I mean, you're correct, it's wrong. Why? What do you always have to do in IUPAC? Remember, always in IUPAC, find the longest chain. Count carbons. What is the longest chain? But this time we modify. The longest chain that has the OH. I can go 1, 2, 3. This is a propane. and off of the second carbon comes an alcohol. This is a 2-propanol. Or better would be propan 2-ol. Both of these are IUPAC. The bottom one's the better name, but I would accept both. What's the common name for this alcohol? The common name is to take this guy, name him as an alkyl group. Do you remember what that alkyl group is called? That's an isopropyl alcohol. Space alcohol. Notice you must never use slang in IUPAC nomenclature. You must never swear. What do you mean swear? Never take a common name and mix it with IUPAC. Well, how would you do that? Isopropyl, and IUPAC is OL, and make an isopropane or isopropanol. This you might find on Safeway shelves, but it is not a proper IUPAC name. It is slang. It is not acceptable. Okay, so we're rolling along with alcohols. We've learned that alcohols have, in some cases, common names, and sometimes there won't be an easy common name for it. So you can give IUPAC and common names. What happens, however, say if we have a molecule like this, and let's compare this to a similar molecule that has 2 alkenes that we've learned to name. So I'm going to compare this to the diene that puts double bonds where we would have had OHs. We'll name that one first. So simply, instead of the OHs, I've got double bonds. Now, as usual, you must find the longest carbon chain. So I'm going to count 1, 2, 3, 4, 5. This is a pentane. Replace the ane with ene. That's pentene. There's 2 enes, pentadiene. So 1, 2, 3, 4. A 2, 4 pentadiene. Or penta 2, 4 diene. So, hello out there. Are you still listening? You awake? Dr. Lloyd never makes a mistake. He only tests to see if you're paying attention. What's wrong with this name I've just written down? I said 1, 2, 3, 4, 5. But I could have numbered the other way, 1, 2, 3, and gotten a 1, 3 numbering scheme rather than the 2, 4. 1, 3 are lower numbers than 2, 4. So the proper name should have been 1, 3, not 2, 4. Aha! Nodding off there, weren't you? Ah, well, that's okay. In any case, how does this name stack up against what we're going to do for here? Well, in the 2 groups, alcohols, we count the longest chain, 1, 2, 3, 4, 5. That is a pentane. If there was 1 alcohol, we drop the E and we add OL. So here's pentanol. But what do we do if we have more than one alcohol? If you have more than one alcohol, and this is what we're going to end up using for all other functional groups, is you use the full pentane again. We go back to pentane. And then we add all with the prefix for 2 in front of it, which in this case 2 is the prefix di, so it's a diol, pentane diol. If there were 3 OHs, it would be triol, 4 would be tetraol, 5 would be pentaol, hexaol, heptaol, octaol, and so on. So pentane diol, now we have to tell you where they are. If I number this way, I get 1, 2, 3, 4, 5. If I number so I got a 2, 4. If I go the other way, 1, 2, 3, 4, I get 2, 4 again, so it doesn't matter. So I get 2, 4, pentane diol, or pentane, now this is tricky, I'm going to have to explain this because you'll notice I dropped the E hyphen 2,4 diol. Remember that bit about silent E's earlier? This E is silent in pentane. If it's followed by a vowel, well, this D is a consonant, so I didn't drop it, or a hyphen, it gets dropped. As long as it's silent, you don't drop penta. Notice I didn't drop the A down here. See this A? There's a hyphen there. Why didn't I drop it? Because it's not a silent vowel. The E is silent. It gets dropped. Now notice a difference between 1,3-pentadiene, his name, and 2,4-pentane diol. You notice it wasn't called 2,4-pentadiol. It turns out that the penta shortening is used for Ynes and Ynes. So you can have pentadiene, pentadiene. But you don't use that for diols or anything else you will see later on. They're always, when you have more than one, the full alkane name followed by diol. Or if you insert the numbers, it's still the full pentane. Then the numbers, then diol. Interesting. What if I have a really complicated structure that has a whole bunch of functional groups, Ynes, Ynes, and alcohols? Let's see if we can generate a nasty structure that we have to name. So here we go, triple bonds. Let's put a couple triple bonds in here. Ooh, nasty, nasty. Okay, in this long chain, we have a series of Ynes, Ynes, and OHs, and there's no way of bringing out Ynes and Ynes in front of the name, so all the Ynes, all the Ynes, and the all will have to be put in the root. What's interesting, I'm going to add one more here. In fact, I'm going to go this way. Now, why not? Should it go one more? I mean, that's 4. Yeah, we'll leave it like that. Okay, so we've got to put these in and we have to number it. The numbering system that you use, if there were just Ynes and Ynes, would go for the lowest overall numbering scheme. You don't worry about the E and 9 priority. But as soon as you add OH, OH is a priority group. Now, we don't go for an overall low numbering scheme, even though it might coincidentally work out. We go for the lowest numbering scheme for the OH, because it's higher priority than Ynes or Ynes in our list. And so if I number from this left-hand CH3, I get 1, 2, 3, 4, 5, 6, 7, 8. If I number from the right, I get 1, 2, 3, 4, 5, 6, 7, 8. In some ways this is easier. Who's better, a 5-all or 4-all? Well, 4-all's lower, so that's the numbering scheme I'm going to use. All right, now an 8-carbon alkane is an octane. If we add our priority OH, that's an octanol. If we add our alkene, that's an octenol. If we add one ine, that's an octene, ine, all. Notice the silent E's are being dropped. And lastly, if there's 2 ines, it's an octene diine all. Now, if we put it on numbers, I could say, because I've got to use the top numbering system, so let's get rid of the lower one that's wrong, erasing it. I'm going to release octane so I can write the name of both versions. Okay. I can start with a 2-octene. My ines are at 5. Ooh. Oh dear. I forgot something. Terrible, 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 terrible. Fix that triple bond. I can't have 12 electrons. That triple bond should have been here. So it won't change anything if I put it in its right place. There we go. That's better. Nothing changes. I just had the triple bond. Please make note of that change here in the structure. So if you're drawing this, I apologize. Ooh, just checking to see if you're awake out there. Very good. Hopefully you noticed that. You can't have 12 electrons around carbon. So coming back, what do we have? 2-octene. Okay. We have 2-octene. How many? Where's my ines? An ine at 5 and 7. So we have a 5,7 diine. And where's my all? The all's at 4, a 4-all. You could also write this as oct-2-ene 5,7 diine. For all. Oct-2-ene 5,7 diine for all. Notice how complicated the names get. But note once again how easy it is to draw the structure if you're given such a complicated name. Very quickly, I am going to draw now a structure. From the name oct-2-ene 5,7 diine for all. I just have to find the root, and the root is oct, and oct means 8, so I draw 8 carbons. Given 8 carbons, I can now put in all of my substituents. At 2, there's an ene, 1, 2, so ene's a double bond. 5, 7, 1, 2, 3, 4, 5, here's a triple bond. 6, 7, a triple bond here. Okay. Now my OH is at 4, 1, 2, 3, 4. Once I put my OH in, I now put in the appropriate hydrogens. This C has only one bond, so there's no hydrogen, so it's a CH3. This C has an H. This C has an H. This C has one H. C's with a triple bond, there's 4 bonds. 4 bonds. There, bang. Done. That's how easy it is to draw these molecules once given the name. Okay. Do we have any specialty common names for alcohols? Well, there is one that comes to mind. And what is it? What do you call an alcohol if it's attached to a benzene ring? Some people might think this should have been called benzenol. Drop the E at OL, and that would be very consistent. What's interesting is this name does not exist anywhere. Benzenol does not exist. An OH on a benzene ring is given a special name you must memorize. And it comes really from the substituent name. The substituent, remember, was called phenol. So the common name for this group is an alkyl name, phenol, followed by alcohol. It looks like IUPAC adopted a name for this alcohol that was based on this common name. The IUPAC name is phenol. Phenol. Okay, so there you have some specialty names. We've seen some differences in the nomenclature of alcohol from alkenes and alkynes. This is a long session, so we're going to break off now.